There really is a supercharger in this box, believe it or not. Here, I'll prove it to you. This is a Rotrex C30 centrifugal supercharger. And over here is an electric motor that's driving that motor, direct drive. This thing makes enough boost and enough air to add 100 horsepower to my Honda S2000. And it'll do that at redline, 8,000 RPM. In fact, I've got a flat boost curve from 3,500 to 9,000 RPM. I can do 7 pounds of boost flat. Now try that with a regular centrifugal supercharger. The question is, why am I doing this? I wanted to add a boost of performance to my 2003 S2000, but I want to leave the car stock as possible. I don't want to modify much. So this actually will drop in right in place of the stock airbox, almost with no modifications of any kind. Let me show you how it works. In the car, the intercoolers will be flipped around 180 degrees. And this will line up right here, which is right where the stock air intake, the throttle body is on the stock car. This whole unit fits in the same place as the stock air box. In fact, this box is a stock Honda S2000 air box. Now it's been modified. I've cut it off. I've got fan cooling. The air intake is going to be right here. I'm going to have cold air coming into this thing. And I've tested it. This guy's ready to go in the car. I'm going to take it apart one last time and tidy things up. But this is 100 horsepower for a Honda S2000 in a box. Let me show you some more. Let me show you how it goes in the car. Here is a stock S2000 air box. There's the air filter. I bought this box off eBay, so I'm leaving the original stock. And this is how it fits in the car, just like this. And this is where the stock air intake is, and that's right where it'll be here. And this guy just drops right in. Here is what my measurements show for our setup of the supercharger on the battery. And this is with the intercooler, with all the charge piping, and also with the air filter. This is everything. It's also got water going to the intercooler. Here's pressure over here, and here's airflow over here. 1.4 is about 6 pounds of boost. 1.7 is about 10 pounds of boost. And this line here is what it will do. So a wide open throttle. If you run the supercharger hard as you can, then it will do 10 pounds of boost at airflows of around 5,000 RPM. And as you increase the RPM, it requires more airflow, and the boost will drop down to about 6 pounds of boost at an airflow that will support about 100 horsepower increase. So 240 stock up to about 340 with this guy. So it's between 6 and 10 pounds of boost depending on airflow, with 6 pounds of boost wide open at redline. Almost 7 pounds of boost at redline. My plan is to run it on this line right here. This is 6 pounds of boost. So it'll be 6 pounds of boost. I'm not going to run the thing as hard as it can. I'm going to run 6 pounds of boost from 3,500 RPM up to 9,000 RPM. And as you can see, that is well under the curve that it can do. So 6 pounds of boost, 3,500 RPM, that takes it all the way down to the surge line. So below 3,500 RPM, I got to start backing off the supercharger or it'll go into surge. So this will be a flat boost curve from 3,500 to RP to redline. For those of you who are following my previous videos, 3 videos on this guy, you'll probably recognize that this looks very different than it did before. It's the same speed controller, the same motor, and the same supercharger, but the battery is very, very different. And before, it fit in the trunk of the car, which I was very proud of, because there's a recessed area in the trunk of the car, and everything except the intercooler fit in that area, recessed down the trunk of the car. My golf clubs would fit on the top of it. It was just a really clean installation because you don't have to worry about the heat of under the hood of the car. It's a nice, cool area back there. And I was going to do a 2-inch charge pipe that went through a hole. I had to put a 2-inch hole in that trunk, in that well, under the car, up in the engine bay to the intercooler. I had to abandon that because when I got a proper mass air meter to measure how much air I was actually delivering, I found out I was delivering less air than I thought. I wasn't going to get to 340 horsepower with the current battery setup. I tried to go to a more powerful LiPo battery, same voltage, put it in an ammo can, but in the end I decided I needed more voltage. I needed a different BMS, and I didn't think the ammo can was really going to save the car if one of these cells went into thermal runaway. So I really wanted to go to an LTO, a lithium titanate battery, which is much safer, but they have great power density. Energy's not that great, but ended up making a large battery. And this is what that battery looks like. It's much, much larger, but it's LTO, it's safer. It's a 32S battery. It's about 15 volts higher than this one was. What makes that possible was I found a battery manager, BMS, that would work with the 32S LTO that could also communicate across a CAN bus to the speed controller, which is something I really wanted. This battery still fits in that recessed area of my trunk, but takes that whole area up. The top of it's flat. This flat area lines up with the main floor of the trunk. So it doesn't really take up any space in the trunk that I care about. My golf clubs will still fit on top of it. Now, instead of a charge pipe taking air forward, I have to have a cable that takes 15,000 watts of power forward to the engine compartment where the supercharger is, the motor is. So this is a cable I designed. This is quite an effort. All my testing is done with the cable, so if it has any effect on the performance, it's being covered in here. A big problem with putting this thing under the hood of the car is heat. This is a street car. Alex LTD is a great source of information, but he's got a race car, and he's got 10 seconds at a time he's got to do, and he can raise the hood. But this thing has to be able to stand stuck in traffic at 100 degrees C, heat soaking, then standing on it and running it hard. And I was very, very worried about the motor and the electronics overheating. So that's why I put this in the air box of the S2000 that has an intake of air right where the stock air intake was. It's a cold air intake. And I've got some massive fans back here that keep the air moving. Let's talk about the Supercharger box itself a bit. Here's the motor. I think it's 120 millimeter by 100 millimeter free RC hobby outrunner motor. Down here is the speed controller. It's a 100 volt, 250 amp VESC speed controller. It turns out right now this is currently the limiting factor on how much boost and power I can make, because I'm coming up against a 250 amp max of this. Yeah, I've pushed it to higher than 250 amps, and I can get more boost and airflow, but it turns out 250 amps is enough to get to my goals. This is the Supercontroller. This is something I've designed, and I'll show you here. Here's an old version of it. So inside of here, there's a custom printed wiring board, and there's an Arduino. This is an ESP32 that mounts in here. These are the fan drivers, and everything else is just resistors and capacitor to kind of interface this guy to the rest of the world. You can see all the changes. This thing has changed pretty dramatically. The big difference on this one is I've added a CAN interface to this one. So this guy talks to the speed controller through the CAN bus. It receives like temperature data, motor temperature data, and back from the speed controller with the CAN bus. It tells the speed controller how hard to drive the motor. That comes from the ESP32 through the CAN bus. We also get information about the battery across the CAN bus. So all three of these guys talk together through the CAN bus. Here's 12 volts coming in. This drives a switch here. This is a 12 volt switch. Switches around 25 amps to the battery charger. The battery charger runs all the time. So there's a built-in battery charger here, and it runs all the time. So it's always charging. As long as the engine's running, it's charging. And but I can turn it off and on with this switch. And there's times when I do want to turn it off. And right here, this engine in 2003, Honda was not using a kind of a modern control strategy where everything is controlled over the CAN bus. Every sensor, everything had its own wire to it. And since I'm using the stock ECU without reprogramming it, because I can't, in 2003 it was not programmable, I have to do all my control with discrete wires. So one of these wires is a ignition coil. So every time a coil fires, the ESP32 knows about it, and I've got a tachometer programmed into here, so this knows the engine RPM. The other wire is a throttle position sensor, so it knows the RPM and the throttle position, and based on that, it's going to command the speed controller to drive the motor at a level that at full throttle gives me 6 pounds of boost at all RPMs. And we'll talk more about that later. If you notice, there's some foam around the outside of this box. That's to control the airflow. The airflow path is out the fans. The fan pulls air from inside the box, which comes down this hole. This foam here keeps it from going anywhere else. This air coming here has to go down through here, and it comes up from here. This, of course, the box is covered over the supercontroller and out the input, and this is the front of the car where the cold air comes into. There's two fans. The two fans are coaxial. I'll show them to you later. But this outer fan is sucking air into this box, which pulls air down and tries to cool the rotors it spins by. So air is going down through here. Then there's a smaller fan that blows out to the center of that one, and it's sucking air to the center of the motor, where the stator is. So the stator and the rotor are cooled separately. Although if one fan fails, it will still cool. It just cools best with both fans. I like having a little redundancy, but it definitely cools better with both fans. Here's a very quick demo of how this thing's going to operate. This is an Arduino that is programmed. Every time I push the button, it's going to increase the RPM by 1,000 RPM. So this is sending out a pulse to the supercharger, to the supercontroller, that looks like the ignition firing. I put a scope on the car, and so I duplicate that. So this is my little test engine for the RPM. This is the throttle position controller, and it's right now it's programmed to the supercharger will turn on at 3.5 volts, and it will gradually increase power up to 4.5 volts. So the blower doesn't just turn on with the blast, it's progressive as you add throttle, and that's adjustable. I'll play with that on the car. Right now at 3.5 volts it comes on, it increases until at 4.5 it hits maximum. And the higher the RPM, you watch the boost gauge go up because it puts out more air as the RPM goes up. Now in reality the boost will be constant because I've got a fixed restriction in here that doesn't really behave like the engine. So you're going to see the boost gauge go up as I increase the throttle here. I'm putting my ear protection on because it's about 115 dB. This is, I'm going to crank it to full throttle. Now I'll show how at, say at 9,000 RPM, the boost builds progressively with throttle. This is a rising rate fuel regulator. This is what I'm going to use to get more fuel for the engine. I did something very similar with my nitrous, where the nitrous kit I used bled a little nitrous off, and it bumped the fuel pressure up. And with a 100 horsepower shot, I had plenty of fuel doing that. In addition to this, I've learned a couple of tricks about how to play with the timing and do a few things by tweaking some sensors. So we got to play with that quite a bit once I get it running. I'll start with 2 pounds of boost and very slowly work my way up, make sure the fuel is good. An obvious question is, how long will this battery last? And I'm pretty sure I know, done some calculations. It's about like this. Without recharging, this battery is roughly equal to a bottle of nitrous, which I usually say is about 100 horsepower for 100 seconds. And of course, this is going to recharge. So it's kind of like having a bottle of nitrous, and then an hour to 2 hours, about the charge time, you'll have a new bottle of nitrous. So you're constantly getting a new bottle of nitrous once every hour or two, depending on how fast I can recharge this thing. Now, I had this bottle in my car, and I never went through a bottle of nitrous in an hour, I can tell you that. So I don't think the battery capacity is going to be much of an issue. I think I'm going to end the video right here. I know I said I'd talk about the battery and some other stuff, but I think this is long enough. I'll do some more videos, so we'll see what kind of interest I have. I plan to do a video on the battery. We'll do one on the Arduino and how it controls everything, and the CAN bus. I learned a tremendous amount doing that. And then I'm going to take this whole thing apart, and I'll film that. So if you want to see how this thing goes together, you can just watch that video. And of course, then once this guy goes in the car, I'll show you how well it works. Not just how much horsepower it makes, but we'll talk about how it drives and the issues with charging the battery and that sort of a thing. But that's all for now. Till next time.